questions on the homework? Nope. So the first one we're going to look at is addition. Adding and subtracting polynomial terms. There's two ways that we can add or subtract polynomial expressions. We can add them vertically or horizontally. We're going to look at vertically first. If we add two polynomial functions vertically, the first one is that we list out our first polynomial expression. So our 3x cubed plus 2x squared minus x minus 7. Now if there are any terms missing, we would leave a space for them. But here we don't have any missing because we do have our x cubed term, our x squared, our x term, and our constant term. What we do next is we put the other expression underneath, lining up the like terms. So we put our x cubed under 3x cubed. We put our negative 10x squared under our 2x squared. Since we do not have an x term, we're not going to put anything under the x. And we'll put our plus 8 under the minus 7. Now at this point here, because again we're adding the two expressions together, we're going to add all the way across. Now I put addition sign between each like term just as a reminder that we are adding the two together. So the first thing we'll do is 3x cubed plus x cubed is 4x cubed. Then we move on to the next one, 2x squared plus negative 10x squared. Or 2x squared minus 10x squared is negative 8x squared. Negative x plus, well, we don't have anything to add to it, so it just stays negative x. And our negative 7 plus 8 is plus 1. And that's it. Questions on this here? It is a little different to add it vertically because we're more used to adding or subtracting horizontally. Because we add or subtract horizontally, we can just rewrite it 9y cubed plus 3y squared minus 2y plus 1 is being added to the quantity, negative 5y squared plus y minus 4. So we're adding the two together. Now since there's not a sign in front of the first set of parentheses, we can just drop the parentheses. And since we're adding, the signs for the second one stay the same. So it'll still be negative 5y squared, positive y, and negative 4. The next thing we can do is put our like terms next to each other. Well, 9y cubed does not have any like terms, but our positive 3y squared does, and it is our negative 5y squared. Our negative 2y and y plus y are like terms. And lastly, our positive 1 and negative 4 are like terms. So we can put our like terms next to each other and then combine them. So since 9y cubed doesn't have any like terms, it's just going to stay 9y cubed. However, our 3y squared minus 5y squared is negative 2y squared. Negative 2y plus y is negative y. And lastly, 1 minus 4 is negative 3. And that's it. Questions on these here? How do we feel with addition and subtraction? Feel good with these here? We need to see another example of addition and subtraction, or addition at this point. We haven't done subtraction yet. Nope, we feel good with adding two polynomial expressions. We can also subtract two polynomial expressions. One more, there we go. And with this here, if there's a missing term, so the biggest term we have is our x cubed, so the one that should follow it is our x squared, which we do have. We have 6x squared. The one after that would be x to the first, or just x. If we didn't have that term, we would leave a spot. But here we do indeed have our minus x, and then our constant term, which is plus 1. Our second expression, we will line it up. So the 8x cubed will go under our x cubed term. Our negative 3x squared goes under our squared term. The negative 2x goes under the x term. And our constant term 9 goes under the constant term. We line up our like terms. And at this point, we're going to subtract the two expressions from each other. Questions before we start subtracting? Now at this point here, 2x cubed minus 8x cubed is negative 6x cubed. 2 minus 8 is negative 6. So we still have our x cubed. 6x squared minus negative 3x squared. Well, negative and negative make a plus. So 6x squared plus 3x squared is plus 9x squared. Now we can't type the whole thing into the calculator because the calculator needs a value for the variables. But we can type the numbers in front, because we could say 6 minus negative 3 in the calculator, which would give us 9, or 6 plus 3, and we add our x squared. Our next one, negative x minus negative 2, again, negative and negative would make a negative x plus 2x is plus. And lastly, 1 minus 9 minus 8. And that's it. Questions on this here? Vertical is a little bit nice with subtraction because it does help us keep track of some of our signs, minusing negatives. But we can also do this horizontally. Now, since there's not a sign in front of the first set of parentheses, we can just rewrite it. Because none of the signs are changing, so we'll just drop the parentheses. Now, since we're subtracting the second set of parentheses, we do have to apply that minus, that negative, to every term inside the parentheses. So our positive 2z squared becomes negative 2z squared. Our positive 3z becomes negative 3z. Now, just like with our addition, we can reorganize it so that our like terms are next to each other. Or if we want to, we can go on and just combine the like terms. Because 3z squared and negative 2z squared are like terms, yes? What's 3z squared minus 2z squared? So 3 minus 2 would be 1, leaving us with z squared. Our next set of like terms are positive z and negative 3z. What is z minus 3z? Negative 2z, because we have 1z minus 3z. 1 minus 3 would be negative 2. And lastly, we have negative 4, which does not have any like terms. It's just negative 4. So the final answer is z squared minus 2z minus 4. Questions on subtraction? We feel comfortable with subtraction? Do we need to see another version of subtraction? So how do we feel with addition and subtraction? Feel good with these here? All right. Feel good with those there. We'll move on to multiplication. Now, it is possible to multiply vertically. It's just a little odd, especially with polynomials. It does work, but I think it's a little bit easier just to keep multiplying horizontally. Because we've done horizontal multiplication pretty much all through Algebra 1 geometry. We're just going to stick with it. And we multiply horizontally. First thing we're going to do is just distribute our negative x squared. Negative x squared times x is negative x cubed. Our negative x squared times negative 3, negative times a negative is a positive, and x squared times 3 is 3x squared. Now that we finished distributing with the negative x squared, we can move on to the 2x. 2x times x is plus squared, plus 2x squared. 2x times negative 3, negative 6x. And it brings us to our last one, our 4. 4 times x is plus 4x, and 4 times negative 3 is negative 12. Questions on how we multiplied this through? Now, one thing that is nice is that all of our like terms for this problem here are all next to each other. Kind of worked out that way. Negative x cubed does not have any like terms, but 3x squared plus 2x squared is plus 5x squared. Negative 6x plus 4x is negative 2x minus 12. That's it. Questions on this here? We can look at the next one. So this one here, we're multiplying y plus 5 by 3y squared minus 2y plus 2. And again, we can do the same thing we just did. We'll distribute and multiply through. Y times 3y squared is 3y cubed. Y times negative 2y is negative 2y squared. And y times 2 is plus 2y. And the next thing we can do is distribute the 5. 5 times 3y is plus 15, well, y squared, because it should be 5 times 3y squared, but just 3y. So it gives us 15y squared. 5 times negative 2y is negative 10y. And lastly, 5 times 2 is plus 10. Questions on how we multiplied this through? Now this one here, are the like terms next to each other? No. But we can either, one, rewrite it so that they are, or we can just go on and combine them. Either way works. If we went on and just combined them, well, 3y cubed doesn't have any like terms, so it is by itself. Our negative 2y squared plus 15y squared would be negative 2 plus 15 is plus 13y squared. And we have our 2y minus 10y. 2 minus 10 is negative 8y. And then lastly, we have our plus 10. Questions on this here? Questions on multiplication? Do we need to see another example of multiplication? I feel pretty comfortable with these here. All right. I do want to look at this one here. It wants us to multiply x minus 1, x plus 4, and x plus 5. So for this one here, we're multiplying three things together. And whenever we multiply two or more things together, we just have to do it part by part, because we can either start off by multiplying x minus 1 times x minus 4, or if we wanted to, we could do x plus 4 and x plus 5 first, or the other way we could start is x minus 1 and x plus 5. Which two do we want to multiply together first? X minus 1 and x plus 4. And we'll do it the exact same way we've been doing it on the previous ones. We'll start off with x times x, which is x squared. X times 4 is going to be plus 4x. Then we'll move on to the negative 1. Negative 1 times x is negative x. And negative 1 times 4 is negative 4. Now we still leave the parentheses around it because we still have to multiply it with the x plus 5. Questions on any of this so far? Now at this point we could start multiplying, but I would highly suggest combining any like terms first before we do any multiplication, because our 4x minus x is positive 3x. We would still get the same final equation if we left it as 4x minus x. We would just have two more like terms that we'd have to work with. Now lastly, we just need to distribute through. We'll do x squared times x, which is x cubed. We'll do x squared times 5, which is plus 5x squared. Then we move on to the 3x. 3x times x is plus 3x squared. And 3x times 5 is plus 15x. And lastly, we distribute the negative 4. Negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. Last but not least, we do need to combine our like terms. X cubed doesn't have any like terms. But our squared terms, 5x squared plus 3x squared is plus 8x squared. 15x minus 4x is plus x. And then we have minus 20. And that is it. Questions on any of this here? So this here is not a whole lot different than what we did with the multiplication before. We just did it once and then did it again. Questions on anything we've done so far? We feel pretty good with multiplication of three terms. Now there are some special product properties that we have, some in difference. This is just the difference of perfect squares, because a squared minus b squared is equal to a plus b times a minus b. So we can kind of do it in a reverse direction. if I notice that I'm multiplying two things that are the same except for the sign in the middle, it really works out to be the first terms squared minus the second term squared. And we do have a similar properties with square binomials and square of, or cubed of binomials, cubing a binomial by itself, that work out in these special ways here. So if we look at this first one, n plus 5 times, or 4n plus 5 times 4n minus 5. Same set of numbers, but different sign. Well, according to that property we just had, we take the first term and square it, multiply by itself, which would be 16n squared, and minus it from the second term being squared, which is 25. Or if we do this, just go on and multiply it out, we will get the same exact answer. Because 4n times 4n, 4 times 4 is 16, and n times n is n squared. 4n times negative 5, well, we'll have negative. 4 times 5 is 20, and we still have the n. The next one, 5 times 4n, is going to be plus 20n. And lastly, 5 times negative 5 is negative 25. Our negative 20 plus 20, 20 and 20 would cancel, leaving us with 16n squared minus 25. Which is the same thing we got there. So it's not, it is a little bit quicker to jump to the 16n squared minus 25. But if we don't see it, it doesn't hurt us in just doing the one step and getting there also. Questions on this here? Now, if we look at the middle one, 9y minus 2 squared, well, the square is really just telling us that we're multiplying the 9y minus 2 by itself. So we can rewrite it out as 9y minus 2 times 9y minus 2. At this point here, we can distribute and work through multiplying out. So we can do 9y times 9y. 9 times 9 is 81, and y times y is y squared. 9y times negative 2. 9 times negative 2 is negative 18, and we have our y. Then we'll do negative 2 times 9y, which is again negative 18y. And lastly, negative 2 times negative 2 is plus 4. We do need to combine our like terms, telling us that we have 81y squared minus 36y plus 4. And that is our final answer. Questions on this here? Any questions on any of this here? Because even with the cube, we would just end up doing it 3 times instead of twice. And it should end up giving you a cubed b cubed plus 312 a squared b squared plus 1648 AB plus 64 if you worked it all the way out. Yeah. As you multiply by itself. I mean, AB is a term because, I mean, we could say that it's AB whole thing cubed, but A cubed, B cubed is also the same thing. Yeah, we would apply it to both. If it is, I would just multiply it out one at a time. Just AB times AB. A times A is A squared. B times B is B squared.